Students, I told you there are different types of stress and different types of strain. So we will see one by one. Okay. So before that, there are three ways in which a solid may change its dimension when an external force acts on it. So we have an idea that when an external force acts on it, there are three ways the body can change its shape or size. The first one is lengthwise. So if I apply two forces, one from this side, another from this side. See, if I apply like this in this direction, okay, what happens? Its length will get changed and the length becomes L plus delta L. So this is nothing but delta L. So we call it as a small change. Okay. Then the similar way, if I compress, if I reverse the direction of force, okay, what will happen? The wire or whatever cylinder whatever we have taken here will get compressed. So what happens to its length? So there will be a decrease in length by a quantity of delta L, and we will say that it is compressive. So here in the case it is tensile stress. Okay, if you consider stress, it will be tensile because length increases. Here it will be compressive. So together, this compressive and tensile, we can say it as longitudinal. So this is one of the ways in which a body can change its shape or size. That is longitudinal. Second one, so I have considered a cylinder over here of length L. If I apply a force over here, see, like you can take a big book, okay, a thick book, and what you do is you apply a force on the top of that. In this direction. See, you are taking a book and you just apply force on the top of that. Then what happens? You can see here, the lower point will be on the same position without changing. But what happens to the top position? It will get displaced tangentially. Why? Because tangentially, because you can see here, there will be a change in the angle. So this was 90 degree actually. Okay, now what happens? You can see here there is a change in the angle, or you have a small angle theta developed over here, and also there is a displacement delta x from the initial position. So such type of change will be called as tangential or shearing. So what we call it as tangential or shearing. Okay, the next one is volumetric. Volumetric means you can understand, if you put something inside water, equal force will be acting from all the sides. So if I take some circular type material, what will happen? Obviously there will be force acting like this. Okay, so what happens? I'll reverse the direction of force over here. Okay, so force will be acting, and whatever object of this much dimension, see, outer circle, will become, or it will be reduced to the size of the inner circle. So what actually happens here? Equal force will act from all the sides so that the body gets compressed. Okay, so this is known as volumetric change. The volume changes. Volume means you know, right? Okay, so volume itself changes. That means dimension from all the sides changes equally. Okay, so these are the three things what we need to study. First one is longitudinal, next one tangential or shearing, then next one is volumetric. Okay, now we will see one by one. So longitudinal stress, you know there are two types. Okay, first one is tensile stress, another one is compressive stress. So what is this tensile stress? Already you have seen this. When a body is stretched by two equal forces applied normal to its cross section, okay, or cross sectional area, the restoring force developed per unit area is known as tensile stress. So remember, stress is not nothing, not the force what you are applying, it is a force what is developed inside that to restore the original position. So if I apply some force over here, see, if I apply some force, this is tensile, then what happens? Its length increases, right? If I remove this force, it goes back to its original position. That regaining force is known as the stress. Okay, that force per unit area is known as tensile stress. Similarly, compressive stress. So what do we do here? We compress it, right? So here I have told we apply force, equal force from both the sides, so that its length becomes reduced to L minus delta L. So here, when a body is compressed under the action of applied force, the restoring force developed per unit area is known as compressive force. Okay, so when a body is compressed, the restoring force developed will be the compressive force. So the stress whatever developed will be known as compressive stress. Okay, next one is longitudinal strain. So we have already seen in the last class about strain. What is strain actually? It is a change in dimension, ratio of the change in dimension to the original dimension. So you know how this longitudinal change happens. It happens like length changes, right? Either like length increases or the length decreases. So we can say here longitudinal strain, it is nothing but the change in the length to the original length. So we take it as a ratio of change in the length to the original length. So we can write it as longitudinal strain, that is nothing but delta L by L. What is this delta L? See, we have seen there, what is delta L? Small change. So if you elongate it or if you compress it, there will be a small change happens to the length. Okay, ratio of that length to the original length of the material. So that is known to be longitudinal strain. Okay, next one, tangential or shearing stress. So we have already seen about tangential or shearing in the previous explanation. Now I'll take the stress over here. It is a restoring force per unit area developed due to applied tangential force. So it is the, say we have taken the book, right? So this is the book what we have. We apply a force in this direction on the top of the book. Then what happens? The top, okay, when you apply a force on the top of the book, what happens? The top part gets displaced. Now what is stress actually? The force that should be developed on the top of the book that has to bring it to the original position. Okay, so that restoring force per unit area, okay, will be known as tensile or shearing stress. It is not tensile, it is tangential or shearing stress. Okay, now you can have any notation because the specified notation is not given for that. So let me take this as a tangential stress, that will be equal to the tangential force divided by unit area. Okay, so this is the notation what you can have. So similarly, tangential or shearing strain. So what we can call this tangential or shearing strain. So it will be the ratio of relative displacement to the length. So it is simply nothing but delta x divided by L, right? Correct. Why? This is a delta x is nothing but the relative displacement to that of the length of the cylinder or whatever we are taking the material. Okay, now you can write this as shearing strain or tangential strain, both are same. Okay, you can just remember that it will be equal to delta x divided by L. Now you see here in this diagram, delta x by L with respect to this theta will be nothing but opposite by hypotenuse. Sorry, not opposite by hypotenuse, opposite by adjacent. And what is this opposite by adjacent? It is nothing but tan theta. So we can write this shearing strain that is equal to tan theta. Okay, so it is mentioned over here, shearing strain will also be equal to tan theta. So usually this theta will be very small. Okay, whenever you apply some force, it is not that a lot of displacement takes place. So very small theta will be developed over there. That's the reason why we can take tan theta approximately equal to theta, or shearing strain can be written as tan theta, or it is approximately equal to theta. Okay, this is about tangential or shearing stress. So don't need to confuse with the tangential with the tensile. Okay, they are different terms. Tangential means you can remember with the tan theta, it is shearing. Okay, so displacement on the top. Tensile is nothing but lengthwise. Okay, next one, the last one over here is volume. So volume stress or hydraulic stress. So volume stress is also known as hydraulic stress. Okay, so internal restoring force, okay, per unit area, it is known as volume stress. So you can understand over here, there I have explained. So if you apply some force, so volume force will be like equal force from all the direction. Now what happens? The shape of this material gets reduced to this one. Okay, dimension got changed. When I remove all these forces, what happens? It comes back to the original shape, right? Correct? It comes back to the original dimension. Therefore, the internal restoring force per unit area is known as volume stress. Okay? Internal restoring force. Now, what about volume strain? Volume strain is simply the ratio of change in the volume to the original volume. It's very simple. So all these things will be asked for 1 mark. Like you will be asked to define the terms like stress, strain, then different types of stress, different type of strains. Okay, all those things will be asked for 1 mark. So what you need to do is you have to read this NCERT textbook thoroughly. Okay, so we will continue in the next class.